Hello, my name is Desmond Edaguse, and I welcome you to mathematics class today. Today, we'll be looking at the theme, statistics. And of course, our topic for today is probability. We're going to have a series of videos on probability, and this is the first of our series. Now, here are some of the things that we will learn in today's video. Today, we'll do an introduction to what probability is. We'll learn about the various terms used in the study of probability. We'll find out what instruments are used in probability. We'll learn what experimental probability is. And finally, we'll carry out some calculations in experimental probability. Now, what exactly is probability? Okay? The word probability, of course, brings to your idea, I guess, probable, something that is possibly going to happen. Now, probability is simply a measure of the likelihood that a particular event or a set of events will occur. That is the possibility that something will happen. Probability is quantified as a number between 0 and 1. If we have a probability line that looks something like this, a continuum from 0 to 1, okay? The point 0 signifies or quantifies the probability that will not happen, that is impossible, while 1 represents the possibility or probability that an event will certainly happen. So 0 signifies impossibility, while 1 signifies a certainty that an event will happen. So probability ranges between 0 and 1. The higher the probability of an event, the more certain that that event will happen. Let's take a typical example. When you toss a coin, okay, a fair, unbiased coin. When we say fair or unbiased, a coin has a head and a tail. Okay, that's how a coin normally is. One side shows the head of maybe a noble person or somebody popular in your country, while the other side is considered to be the tail. Now, a fair coin looks exactly like this, while a biased coin could probably have 2 heads and 2 tails, which is not common. So let's assume we have a fair coin. Now, if that coin is tossed, there is a probability of having only 2 possible outcomes. Either you have a head or you have a tail. So the head and the tail are both equally what? Probable. In other words, the probability of the head is 1 out of 2 possible outcomes. That is, it's half, or you may say 50%, or you may say 0.5. And also the probability of a tail is also 1 out of 2 outcomes. So it's either we write that as half, or 50%, or 0.5. So in our probability line, we have the midpoint of our line to be 0.5. Okay, so the possibility of getting a head or a tail falls within this region. Now let's go on. Now there are different terms used in the study of probability in mathematics. Here are some of the terms that you will be coming across in the study of probability. Experiment or trial. Either words may be used. What is an experiment? Okay? An experiment is an action where the result is uncertain. Probability deals with uncertainty. Okay? Where the result is uncertain. For instance, tossing a coin, throwing a dice, etc. You cannot predict what number you will get when you throw a dice. So you may have 1 or 2 or 3 or 4 or 5 or 6 come up. All right? So the experiment of throwing that dice is the action of throwing the dice or tossing a coin upwards to get head or tail. That action is called an experiment. Sample space What is a sample space? The sample space, okay, is all of the possible outcomes of an experiment. When you throw a dice, you have 6 possible outcomes. So you get either 1, 2, 3, 4, 5, or 6. Come up. Okay? Also, for another example, when you choose a card from a deck of 52 cards, okay, a normal deck of cards has 52 cards in them. Now, the sample space is all of that possible number of cards. If you pick a card out of the 52 cards, we say the sample space of that experiment of picking that card is 52. So there are 52 possible cards. Just like in a dice, there are 6 possible outcomes. And in a card, you have a sample space of 52. Sample point. Now, the sample point, for instance, the issue of the card we just had, when you consider just one possible outcome, we say that is the sample point. For instance, if you pick the 5 of clubs from a deck of cards, okay, that is a sample point. Just one possible outcome out of all the 52 possible outcomes. Event. What is an event? An event is a single result of an experiment. For instance, rolling a 5 from a dice. You roll a dice and you get 5 as a result. That is an event. Okay? Events can be independent. When you have an independent event, it means that that event is not affected by other events. Now, within, for instance, a particular deck of cards, you pick a card out, okay, and you determine the probability of that particular card that was picked. You put it back to pick another card. Now, the first event was picking the first card. The next event is picking of another card. They are independent because when you pick the second card, it was still 52, still complete, because the initial card was replaced. When you have such an instance, for example, you have an independent event because the first event did not affect the second event. Now, dependent events, also called conditional events. This is where events are affected by other events. So the first example we gave, if you pick that first card and you take it out of the deck of cards, instead of 52, you now have 51. When you are picking the next card, you find that you have a lesser sample space. So in that instance, you have a dependent event. The first event affected your second event. And finally, another type of event is called the mutually exclusive events. These are events that cannot happen at the same time, okay? So if you throw a dice and at the same time pick a card, they do not affect each other. They are 2 separate, okay, actions. In such a case, they are mutually exclusive. Now, in carrying out experiments in probability, we normally make use of 3 basic instruments. These are the instruments. These instruments are referred to as chance instruments, and they are dice. We also use the coin, like we explained earlier, where you have the head and the tail. Okay? And we also use a deck of cards. A normal deck of cards has 52 cards in them. Okay? It has 4 suits. We have the spade, we have the club, we have the diamond, and we have the hearts. Okay? So each of these suits, like we've listed, have 13 cards each in them, which, when summed up, gives us 52. So in a deck of cards, you have 52 cards within them. And in that deck of cards, each suit, okay, you have ace, you have jack, okay, you have your king, and you have the queen. All right, and then you have numbers 2 to 10. All right, so it's important you know this information concerning deck of cards. in the course of probability, you may be asked questions that has to do with cards. So get familiar with a typical card or typical pack of cards. All right? Next, we'll learn about experimental probability. What is an experimental probability? Experimental probability, okay, is the ratio of the number of times an event occurs to the total number of trials or times the activity is performed. Okay? It is the probability that is determined from the result of actual experiments that are carried out. For instance, the rolling of the dice is an experiment. Drawing cards is an experiment. We can have so many different experiments, okay? It is what actually happened rather than what you were expecting to happen. So experimental probability deals with results of actual experiments that are carried out. We said earlier that the probability that something is certainly going to happen is 1. Remember, we drew the probability line. While the probability of something that is impossible is 0. The probability of something not happening is therefore what? 1 minus the probability that it will happen. This is a typical formula used to carry out experimental probability. So experimental probability is number of required outcomes, okay, all over the number of possible outcomes. That is your sample space. The number of required outcomes from the question given all over your sample space. That is the total number of possible outcomes that could take place. Now we'll carry out some calculations on experimental probability for better understanding. A die, okay, die is simply your dice, okay, is rolled 200 times. Now the outcomes are obtained as shown in the table below here. We've been asked to find the experimental probability of obtaining a 2, a 5, and a 6. Let's look at our table. So we have 1, that's the side of our dice, showing 1, say for instance. This side was found to appear 25 times. It was rolled 200 times. 1 appeared 25 times. 2 appeared 30 times. 3 appeared 45 times. 4 appeared 28 times. 5 appeared 40 times. 6 appeared 32 times. When you add up the number of times, you have 200. That is, it was rolled for 200 times. Now we've been asked to find the experimental probability of obtaining a 2. Let's look again at the formula we looked at just now. Probability is what? The number of required outcomes all over the number of possible outcomes. Now, the number of required outcomes is what? 2. This is what is required. 2. How many times did 2 show up on our dice? It showed up 30 times. So that's the number of our required outcomes. All over the number of possible outcomes. How many times was the dice rolled in total? 200 times, of course. So we simply say 30 all over 200. 30 all over 200 is what? 3 all over 20, which gives us 0.15. So the probability of obtaining a 2 is, you can put your answer in a fraction form or a decimal form. So the probability is either 3 over 20 or 0.15. Next, let's find the probability of obtaining a 5. 5 here was rolled how many times? 40 times. Total number of possible outcomes, 200. So 40 all over 200 is what? 4 over 20. When you divide further, we have 1 over 5, or we say 0.2. Probability of obtaining a 6, following the same steps, we say 6 was rolled 32 times. 32 all over 200. All right, that gives us 4 over 25, and of course, which is 0.16. Again, the table shows the number of male and female children in Emeka's family. Estimate the probability that Emeka has a male child or a female child. Again, our probability is number of required outcomes over number of possible outcomes. So the required outcome is first a male child, and the other question also says required outcome for a female child. So let's study our table. From the table, we have the number of males and the number of females from the family of Emeka. From Emeka's mother and father, there are 2 sons and 2 daughters. From the father's brothers, there are 3 sons, no female. From the father's sisters, there are 3 males and 6 females. From the mother's brothers, there are 8 males and 4 females. From the mother's sisters, there are 4 males and 2 females. When we add all our males up, we have 20 males. If we add up all the females, we also have 14 females. All right? So we have the values that we need. To get the probability that Emeka has a male child, okay, the number of required outcomes, total males, 20, all over the total number of children. So here we need to add up the male and female children. So 20 plus 14, this gives us 34. So the number or the total number of possible outcomes is 34. 20 over 34 is 10 over 17, which is also 0.59. So the probability of a male child in Emeka's family is what? 0.59. Now let's look at the probability of a female child. Total number of females is 14. Total number of possible outcomes is 34. So we simply say 14 over 34, which is 7 over 17. And this gives us 0.41. Now let's take another example. The table shows the number of pupils in each age group in a class. Here's our table. Now within the class, we have pupils that are 13 years old, 9 of them. Pupils that are 14 years old, 26 of them. Pupils that are 15 years old, 5 of them. What is the probability that any child chosen at random from the class will be over 13 years old? And what is also the probability that any child chosen at random from the class will be 14 years old or less? Let's take them one after the other. First, let's remember our formula. Probability is what? Number of required outcomes over number of possible outcomes. Now, the number of pupils over 13 years old are all pupils that are 14 and all pupils that are 15. They are all older than 13. How many pupils are 14? 26 of them. How many of them are 15? 5 of them. So we have 26 plus 5, and that gives us what? 31. So our required outcome is 31. All over, the total number of possible outcomes is the total number of students in our class. That is 9 plus 26 students plus 5 students, which gives us 40 students. The probability of having pupils over 13 years old will be 31 over 40. Next, let's find the probability that a child chosen at random will be 14 years old or less. 14 years old or less. How many pupils are 14 years old? 26. 13 years old is less than 14 years old. So how many pupils are 13? 9. We have 26 and 9, and that gives us 35. So the number of our required outcomes is 35. Of course, we know the number of our total number of students is 40. So 35 over 40, and that gives us 7 over 8 as our answer. Another example. Out of every 1,000 cars, 50 develop mechanical faults within 3 months of purchase. Okay, this was documented. So what is the probability of buying a car that won't develop a mechanical fault within 3 months? Again, probability is number of required outcomes over number of possible outcomes. Let's get our number of required outcomes. Now, 50 cars develop faults after 3 months out of 1,000 cars. So it therefore means that the number that did not develop faults will be what? The total 1,000 minus the 50 that developed faults. That means 950 cars did not develop faults within that 3 months. So we have the number of our required outcomes. Okay? Because it was required for us to find the probability of buying a car that won't develop mechanical faults. 950 did not develop mechanical faults. And we say the number of possible outcomes, of course, is 1,000. So you simply say 950 over 1,000, and that gives us 0.95 as our answer. Now, in summary, let's look at what we've learned today. We learned what probability is. We say probability is a measure of the likelihood or the possibility that a particular event or sets of events will occur or happen. We learned what experimental probability is. We said it's the ratio of the number of times an event occurs to the total number of trials or times the activity is performed, that is, the experiment is done. It's the probability that is determined from the results of actual experiments that are carried out. We learned about the different instruments for experimental probability, which we call the chance instruments. We learned that we make use of dice, coin, and playing cards. We learned about the different terms used in experimental probability, or the different terms that we may find in the study of probability. So we learned about experiments. We said there are actions that are carried out without a certain result. Okay? We also learned about sample space, the total number of possible outcomes of an experiment. We learned about the sample point, one possible outcome out of the total number of possible outcomes. And we learned about the event, that is the result of an experiment. And finally, we learned about the formula for experimental probability, which we said is the number of required outcomes all over the number of possible outcomes. And before we go, let's take just 2 quick questions to remember or to see or to test our abilities in all that we have learned today. Now, the table, this table here, shows the number of vehicles which pass in front of a school in a given hour. Find the probability that the next vehicle passing is a bus. Okay? So within an hour, these are the number of vehicles that pass in front of a school. What is the probability that the next vehicle passing will be a bus? Okay? So remember we said probability is what? Number of required outcomes. Okay, all over total number of possible outcomes. Okay, so the number of required outcomes is that of a bus. We have 8 as the number of our required outcomes. What are the total number of vehicles? 27 plus 15 plus 8. That gives us 50. So we have 50 as the total number of our possible outcomes. 8 over 50, of course, if we further simplify this, we have 4 and 25. So our answer is simply 4 all over 25. Let's see which of our options here has the correct answer. Is it A, B, C, or D? Option D is correct. 4 over 25 is our answer. Let's take the second question. There is a bag full of colored balls. Okay, we have red balls, blue balls, green balls, and orange balls. Now, balls are picked out and replaced. John did this 1,000 times and obtained the following results. Okay, 300 times he picked blue balls. 200 times he picked red balls, 450 times he picked green balls, and 50 times he picked orange balls. So 300 and 200 and 450 and 50 gives us the 1,000 times that John did his experiment. What is the probability that he picked or will pick a green ball? What is the probability that he will pick a green ball? Probability, again, we said, is required outcome or number of required outcome all over number of total possible outcome. Okay, so what's the required outcome? Green balls. The green balls were picked how many times? 450 times. The total required outcomes is 1,000 because we had that experiment done 1,000 times. So 5 in 45 gives us 9, of course. 5 in 100 gives us 20. So we have 9 all over 20 as our answer. Let's see which of our options here are correct. Is it A, B, C, or D? Option B is correct. 9 over 20 is our answer. And with that, we end our class for today. There is, of course, going to be a next class after this one. I hope to see you in that class. Try and practice, and the more you practice, the better you become. Once again, I'm Desmond, and I'll see you next time.